Hi everyone, welcome to another Singapore Maths Academy video. I've not done this for a while, so hopefully I'm not too rusty. This is a very special video for Orion, one of our students, one-to-one students who's applying for various independent schools. And so we're going through a few questions that I didn't have enough time to complete and go through with him before his next exam on Wednesday. So let's have a look at these questions. The first one is on my board, and it says here, the diagram shows a car park. Mrs. Roberts is selling the car park. She will accept any offer that is more than £28 per square metre. Mr. Patel offers £194,700 for the car park. Will Mrs. Roberts accept Mr. Patel's offer for the car park? You must show how you reached your decision. Okay, so quite a challenging question actually. I haven't seen something like this on an 11 plus question. Top of my head, I've not seen it at all, so it's interesting. So let's have a look. First we need to work out the area, right? Because it says she'll accept £28 per square meter. Now square meter, we normally associate that with area, so that means the first step is for us really to work out the area of this shape. This is a very unusual car park, that's for sure. So let's see if we can work out the area. What would be the best way to work out the area? I would probably split this up into a rectangle and a triangle if I can, and let's see how that looks here. Let me split it up this way. I think that's about right. Here we are. So now I can see that I've got a 20 meter by 120 meter rectangle. So I know I can work out the area. 20 times 120 meters. 10 times 120 is 1,200. So 20 times that must be double that. So it's 2,400 square meters. So that's the area of the rectangle. Quite simple, right? Let's work out the area of the triangle. This triangle, I know this whole length here, if I'm seeing it right, is 140 meters. And so the length I need for the actual triangle, which is this length here, which is the height, is going to be 140, take away the 20, so that's going to be 120 meters. So we've got a height of 120 meters for this triangle, and then our base is going to be, let's see what it says, this is 42 meters, and I know altogether this is 120, so 120 take away 42 meters is what's going to be the base length here. Right, so 120 take away 40 is 80, 80 take away 2 is 78. So we've got 78 meters here, and I've got 120 meters for height. So to work out the area of the triangle is going to be the base, 78 meters, multiplied by the height, 120 meters, divided by 2. I can do it in different ways. I might half 60, for example, and do 78 times 60. That will give me the same answer here as well. So let's do that. 78 times 60, I can use column multiplication. 78 times 6, I might do that, and then multiply by 10. 6 times 8 is 48. So I'm going to put the 8 here, 4 there. 6 times 7 is 42, plus the 4 is 46. And so I've got 46 here, and so 468. 78 times 6 is 468, and so if it's 78 times 60, that must be 4,680. So far so good. I hope that makes sense how I got the area for the rectangle and the triangle. So the final step really here is to work out the total area of the shape of the car park. So I've got 2,400, 2,400, add 4,680, and when I add that together, I get, what do I get? Let's have a look. 4 plus 6 is going to be 10. So that's going to be 7,080 square meters. So the total the total area for this shape is 70,080 square meters. Now it says Mr. Patel offered £194,700, right? So if it's £28 per square meter, that's what she needs, the minimum kind of acceptable price. We have to divide the amount that he's offering, Mr. Patel, which is £194,700, divided by the square meterage. Okay, that will give us how much per square meter he's offering. So how we're going to do that? Let's see. 194,700 divided by 7,080. 7,080, here we are, is our task. It looks quite a challenge, okay? But what can I do? I can cancel these two because I can divide both of them by 10. And so I can rewrite this as 1,000 or 19,470 divided by 708. Another way I could do this, right? Now, that still seems a bit of a challenge, right? It still seems like it's a big jump from 19,470 to divide that by 708. So we need to kind of work out a strategy that might help us. We could halve both of these, right? So if I divide this by 2 and divide this by 2, that might make it a bit smaller, but still I'm going to have a 3-digit number. It's not going to make a huge amount of difference, right? So that might not be the best way to go about solving this. So how could I solve this? I could split this into numbers that are going to be easier, right? So I know 708 times 10 is 7,080. And so I know I can split into 2 lots of 7,080s. Right, so 14,160 altogether, and I know half of 7,080, sorry, is going to be 7,080 divided by 2 is going to be 3,504. So 3,504, which is 3,504, or is that, I said that wrong? No, 3,540. Is what I meant to say. 3,540. So I know 7,080 divided by 708 equals 10. This also divided by 708 equals 10. This divided by 708 equals 5. So I've got 25 so far. How much does that add up to? 7,080 plus 7,080 is 14,160. And then I've got 3,540. If I add that together, I get 005 plus 1 plus 1, 7, 17,700, which is quite close to the 19,470, right? What's the difference between the two? 19,470 subtract 17,700. What have I got left? 0, 14 take away 7 is 7. And then I've got 8 take away 7 is 1. So 1,700. So I know that's going to be a lot easier to divide, right? So I've got 10 plus 10 is 20 plus 5, 25. And I know 1,700 or 1,700 divided by 708, 7, 14, 21. That's going to be less than 3, right? That's going to be less than 3. So if it's less than 3, because I've got 10, 25, and something that's less than 3, if it was 3, it would be 28. So I know that this is an offer that she's not going to accept. Will Mrs. Roberts accept Mr. Patel's offer for the car park? No, she won't, because Mr. Patel has offered something around £27 something, right? We don't have to be exact here. We know it's going to be less than £28. It'll be £27 something for the per square meter for the actual car park. So question 14 is one of those questions where you have to think of a number. So normally with this type of question, I use algebra. So when it says Claire thinks of a number, she multiplies the number by 9 and then subtracts 10. Thinking of a number, that number could be x. When she multiplies it by 9, 9 times x is written as 9x. And then she takes away 10, so it'd be 9x, take away 10. We're told that the number she gets when she does that is 35. So 9x, take away 10 equals 35. And so this is a simple linear equation that we can solve. And so what I would teach our children in the academy would be we'd add 10 on both sides. And so we have 9x equals 45, and therefore x must equal to 45 divided by 9, which is going to be 5. So she must have thought about the number 5. 5 times 9 is 45. 45 take away 10 is 35, and that's what she got. Okay, perfect. Now the second question is a bit more tricky. Okay, it says Patrick thinks of three prime numbers. When he adds them together, he gets 40. So typically I would just write down the prime numbers. So 2, 3, 5, 7, 8, is it 9, is it 10, is it 11, 13, 15, nope, 16, nope, 17, 18, 19, 20, 21, 22, 23. So these are some of our prime numbers, around or under 20, most of them, and one that's over 20. Now, I might start off with, looking at 2 first. Okay, so if it's 3 numbers, if I put them in order, that would be nice. So if it's 2 as the first number, the other 2 numbers must be 30 take away 2 is going to be 40 take away 2 is going to be 38. So these 2 numbers have to add up to 38. Looking at the numbers, 38 would be like 17 plus 21. That would be 17 is a prime, but 21 isn't. Or 19 times 2 is 38 as well. So this was a bit tricky because you can use 19 twice. It seemed like they were suggesting that it'd be 3 different numbers, but it's actually 19 can be used twice. So Patrick thinks of 3 prime numbers. So there's 2, 19, and 19. That makes 40 altogether. And it says, what's the difference between the 2 biggest of the 3 numbers? 2 biggest of the 3 numbers, 19 take away 19 is 0. There is no difference, okay, between the 2 larger numbers out of the 3. So the other question that I didn't have time to go through with Ryan is this one. I think he's done it, so I think I just have to mark it and unmark it. I'm sure he's doing this right. So 135 degrees is this angle here. We know that these 2 angles form a straight line, and so that must mean that x plus 135 is 180. So I have to do 180 take away 135 to work out what x is equal to. So x is going to be 180 take away 130 is 50. 50 take away 5 is 45 degrees. X is 45 degrees. Now x is 45 and I've got 87 here. 45 plus 87 is equal to, well, 80 plus 40 is 120. 5 plus 7 is going to be 12. So 140 plus 80, I said 120. 120 plus 12 is 132. So these 2 add up to 132 degrees. So Z is just going to be 180 take away 132 degrees. And so 180 take away 130 is 50. And 50 take away 2 is 48 degrees. So Z must be 48 degrees. X must be, 45 degrees. And Y must be 180 take away 48. 180 take away 48 is equal to 132 degrees. And so Y is 132 degrees. So that's your answer for this question. Not too bad, this one, right? For one of the last questions. Right, let's have a look at the next question, question 16. And I think that's it for this paper. These are the only questions that I didn't have a chance to go through with Ryan. So it says a number of triangles and squares are drawn on a piece of paper separately. The 2 number of sides is 110. And there are twice as many squares as there are triangles. How many triangles are there? Okay, so a number of triangles and squares are drawn on a piece of paper separately. So you've got like a piece of paper and another piece of paper. Some of them have squares and some of them have triangles. Okay, the total number of sides is 110. Okay, so we've got 110 sides altogether. And there are twice as many squares as there are triangles. So I know, if I think about the squares, I'm going to write SQ for squares. There's twice as many squares as there are triangles. So I've got that for my squares. I'm going to draw a bar model. And I've got my triangles, which is going to be one of those because there's twice as many squares as there are triangles. Now, all together, number of sides, 110 sides. 110 sides with twice as many squares as there are triangles. Now, I know that in terms of some number of sides, squares have 4 and triangles have 3, right? So 4, 8, 9, 10, 11. So we're going to be looking at squares and triangles, right? And the sides add up together. It's going to be in multiples of 11, right? So if it's 2 squares and 1 triangle, that'll be 4 plus 4 is 8, 9, 10, 11 sides, and that there must be 2 squares and 1 triangle. That would give us 11 sides, but we must have 10 times as many because we've got 110 sides, right? So it's going to be, if I've got 2 squares and 1 triangle, right, I'm going to have 111 sides. I need, so I'm going to have 1 square, 1 square, 1 triangle. That's going to be 11 sides. I need 10 times as many, so this is 2 times 10, which is 20, and this is 1 times 10, which is 10. There must be, how many triangles are there? There must be 10 triangles, right? Because 10 times 3 is 30 sides. And there must be 20 squares, because 20 times 4 is going to be 80 sides. 80 plus 30 is 110. So yeah, 10 triangles must be on this piece of paper. That's about it. So hopefully you've enjoyed these questions and you've been able to solve them. And if you haven't, this video has helped you solve some of these problems from St Benedict's paper. And I look forward to seeing you in our next video. Take care, everyone. Bye.